8.4, example 6. Before we dive into example 6, I do want to go over some definitions. So the first one involves integrals with infinite discontinuities. So when we look at integrals with infinite discontinuities, we are going to learn how to break those up to determine limits and actually evaluate the integrals. In the first one, if f of x is continuous on the interval ab, where a is not included, which is the lower limit, then the integral can be written from a to b as the limit as c approaches a from the right. And then you replace the a with the c. The second one is if the right endpoint is not included, you replace the right endpoint with a c, and you approach b from the left. And if it's on an interval and there's somewhere in the middle that doesn't work, you can go ahead and get rid of that by integrating from a to the discontinuity and then from the discontinuity to the endpoint, which is b. To sum that up, you're going to replace the left endpoint, so the starting point, with c, and then when you're done, take the limit as you approach from the right. If the right endpoint is not included, then you are going to replace the top limit of the integral with c, and then approach c as approaches b from the left. And then if there's an infinite discontinuity in the middle, you're going to break up the integral where the infinite discontinuity is. So an example of that is 1 over x minus 1 to the 2/3. We can see that there is an infinite discontinuity at x equals 1. So if we were to do the integral from negative infinity to 1, you would have to set it up as the limit as you approach 1 from the left and replacing the endpoint, the right endpoint. And if you want something in the middle, like we'll see in example 6, we're going to actually have to break this up into two pieces. So in example 6, we want the integral from 0 to 3 of 1 over x minus 1 to the 2/3. Now we need to make note that, again, there is a vertical tangent at x equals 1, and it's continuous from 0 to 1 and 1 to 3. So basically saying x cannot equal 1. And that's super easy to see. In order to do that, you just look at the denominator and you're like, oh yeah, there's a vertical asymptote. So what we're really looking at is this blue graph. This is really what we want. We want to find the area underneath. So really what we're looking for is this blue shaded region, which is going to be the integral from 0 to 1, and then the integral from 1 to 3. So you just split them up into two pieces, breaking them up where you have that infinite discontinuity. All right, so let's go ahead and work that out. So again, I'm going to split up my integral from 0 to 1 plus the integral from 1 to 3. Now what you actually have to do, and I know it seems silly, is you have to rewrite them with limits because you can't actually plug in 1, otherwise the function will break. Okay, so we have to write this as the limit as c approaches 1 from the left, because it's the top endpoint. And I'm going to go ahead and write this from 0 to c, and I'm going to write x minus 1 to the negative 2/3. Bringing up that fraction is going to make the integrating so much easier. Plus the limit as c approaches 1 from the right, because now you're replacing the bottom limit, x minus 1 to the negative 2/3. Okay. So what you're going to need to do now is either a u sub or go ahead and just do the antiderivative. So this is the limit. C approaches 1 from the left, and it's going to be x minus 1. If you add 1, you're going to get 1/3. And then you have to divide by 1/3, so you get 3 from 0 to c. Plus the limit as you approach 1 from the right. And this is going to be the same thing, 3x minus 1 to the 1/3 from c to 3, or 3 to c. Sorry, 3 to c. Okay, I'm going to work out one and then the other. For me, it works easier that way in my brain. So this is the limit as c approaches 1 from the left, 3c minus 1 to the 1/3 minus 3, 0 minus 1 to the 1/3. So it's the limit as c approaches 1 from the left. This is going to be 3c minus 1 to the 1/3 minus 3 times negative 1. Okay, so as I approach 1 from the left of this, I just plug it in. So I get 3, 1 minus 1 to the 1/3 plus 3. the whole thing zeroes out, and I get 3. Okay, now let's work out the other one. I'm going to do it in green. So plus the limit as c approaches 1 from the right. And this time I'm going to show you a cool trick. You can actually just bring that 3 out because it's a constant. So then I get 3 minus 1 to the 1/3 minus c minus 1 to the 1/3. So I'm going to work that out a little bit before I go ahead and multiply by 3. So it's the limit as c approaches 1 from the right. This is 2 to the 1/3 minus c minus 1 to the 1/3. So go ahead, I'm going to plug in 1 now. So I get 3. This is 2 to the 1/3 minus 1 minus 1 to the 1/3. This whole thing is going to zero out. And I get plus 3 times the cube root of 2. So my final answer is 3 plus 3 cube root of 2. So we get this is about 6.779. And if I go back to my graph and I add, basically this is 3 plus 3.7, I get 6.7, which is what I got here. So it's the same thing.